Bismillahirrahmanirrahim. Assalamu-Alaikum warahmatullahi wabarakatuh. My dear students, once again we are meeting today for a fresh and new lecture from the syllabus of Interchemistry, chapter number 8, Alkyl Halides. And another very important topic from this chapter I am going to discuss today with you people is elimination reactions. Dear students, as far as the definition of the term elimination reaction is concerned, we can define these reactions as those type of chemical reactions during which two atoms or group of atoms are removed from the adjacent or neighboring carbons so as to form multiple bond, means double bond between them, are called elimination reactions, and the elimination reactions are generally symbolized as E reactions. I must recall your memories here when we were discussing the methods of preparation of ethene in chapter number 7. You might recall that one of the methods for the preparation of ethene we discussed here was by the dehydrohalogenation of ethyl chloride. Now what we learned in that particular reaction was we removed the halogen atom from the alpha carbon from ethyl chloride molecule, and we removed the hydrogen atom from the beta carbon, and the reaction was carried out with potassium hydroxide, alcoholic potassium hydroxide. If I write the reaction again here, this was the reaction. This is ethyl chloride, and it is reacted with alcoholic potassium hydroxide. Now what will happen? The carbon bearing halogen atom with it is said to be an alpha carbon, while the next carbon is said to be the beta carbon. So what happens? This chlorine atom will be removed from the alpha carbon. It takes the potassium atom with it to make potassium chloride. Similarly, the hydrogen atom from the beta carbon will take the OH group of potassium hydroxide molecule with it, and another byproduct will be the water molecule. What happens as a result of the removal of this hydrogen and chlorine atoms? Double bond will be formed between the two carbons. The main product you will have will be CH2 double bond. CH2 means ethene molecule will be formed. So this is simply the elimination reaction by which we have removed the hydrogen atom from the beta carbon, halogen atom from the alpha carbon. As a result, we got ethene along with potassium chloride and water. So this is a simple example of elimination reaction by which ethyl chloride was converted into ethene. My dear students, as far as the mechanisms or types of elimination reactions are concerned, in Gould and Hughes, they were the two scientists who suggested two mechanisms for the elimination reactions of alkyl halides. First was named as bimolecular elimination reaction, E2, and the second was the unimolecular elimination reaction, E1. So I am going to discuss the types of elimination reaction before you. So these are the two types of elimination reactions as reported by the Ingold and Hughes in the year 1941. First one is called the bimolecular elimination reaction, which is symbolized as E2, and second one is the unimolecular elimination reaction, E1. So first I am going to start with the bimolecular elimination reaction. Dear students, so many similarities or resemblances you will find between the bimolecular elimination reactions and bimolecular nucleophilic substitution reactions which we discussed in our previous lecture. For example, the first similarity is the SN2 reactions were found to be taking place in the primary alkyl halides. Similarly, bimolecular elimination reactions also take place in the primary alkyl halides. So first point is these reactions take place in the primary alkyl halides. Secondly, another similar thing between SN2 and E2 reaction is they are completed in one step. Third one, the reactants on their way to products pass through an intermediate state called transition state. Where the bonds are shown half broken and half formed. So all 3 points which we are discussing here, we already discussed in the SN2 reactions as well. So I am going to write the mechanism of E2 reactions here. This is a simple alkyl halide called ethyl chloride. The substrate molecule while this is the attacking nucleophile in the form of OH group, which might be taken from any strong base like sodium hydroxide or potassium hydroxide. The carbon bearing halogen atom is the alpha carbon, while the neighboring carbon is the beta carbon. Now what will happen here, being more electronegative, the chlorine atom will try to gain this electron pair with it and break the bond between carbon and itself, chlorine atom. At the same time, this OH group will try to make its bond with the hydrogen atom of the beta carbon. In this way, a transition state will be obtained. In this transition state, the bond between carbon and chlorine is shown half broken by means of dotted line. Similarly, the bond between H and OH will be shown half formed by means of dotted line. This is the transition state. Finally, this chlorine will detach itself from the molecule and it leaves the molecule as the leaving nucleophile. This H and OH make a new bond to make water, and this bond between carbon and hydrogen will be shifted between the two carbons, resulting in the formation of the main product ethene. So this is the mechanism of E2 reaction, the bimolecular elimination reaction. As you all have seen here, that both the substrate molecule and attacking nucleophile are playing their role simultaneously in the reaction. So the rate of bimolecular elimination reactions depend upon the concentration of substrate as well as the attacking nucleophile. So applying law of mass action, I must say if I write it in the form of the symbols, so the rate of bimolecular elimination reactions depend upon the concentration of alkyl halide molecule as well as the concentration of attacking nucleophile. Now, proceeding further, I would like to discuss the E1 reactions with you, the unimolecular elimination reactions, E1 reactions. Dear students, again there are so many resemblances or similarities between the SN1 reactions and E1 reactions. The very first resemblance or similarity is these reactions are carried out in the tertiary alkyl halides. Like SN1 reactions, E1 reactions are also carried out in the tertiary alkyl halide molecules. The second similar thing is Like SN1 reactions, the E1 reactions are also completed in 2 steps. In step number 1, the removal of halogen atom from the alpha carbon takes place. So as to give the tertiary carbonium ion. Now this step is slow, reversible, and the rate determining step. I am writing the mechanism here. If you carefully look into the structure which I have written over here, it is actually tertiary butyl chloride. The substrate being more electronegative in nature, the chlorine atom will try to escape out from the molecule by taking this electron pair with it, resulting in the formation of positive charge on this alpha carbon. As a result of that, this is said to be the leaving nucleophile. This is the tertiary butyl carbonium ion. Now this exactly the same step we discussed while discussing the SN1 reactions, and I must tell you that in one of the papers of MCAT, the MCQ type question came in one of the year that which step is commonly used in E1 and SN1 reactions. So this is the common step between E1 and SN1. Breaking of tertiary alkyl molecule, ionization of tertiary alkyl molecule to give the tertiary butyl carbonium ion and the leaving nucleophile in the form of halogen atom. So this is the similar step between E1 and SN1 reactions. This step is the slow, reversible and rate determining step, because until unless the breaking of alkyl halide molecule does not take place, the attacking nucleophile will never happen, will never take place on the beta carbon. So once the breaking of tertiary alkyl halide molecule occurs, now the second step will be fast and irreversible, and that will be the attack of OH ion. Second step, step number 2. In this step, the attacking nucleophile, which is oftenly taken in the form of OH group, attacks on the hydrogen atom beta carbon so as to form water as a byproduct. As a result, double bond will be formed between the alpha carbon and beta carbon. Now this is the XII butyl carbonamide, and this is the attacking nucleophile, the OH group. Now this OH group will take this hydrogen atom from the beta carbon this step is fast and irreversible. Water will be produced as a byproduct, and this bond between alpha and beta carbon makes a double bond, CH2, double bond C, single bond CH3, single bond CH3. If I name this compound, it is said to be 2-methyl propene, which is the elimination product. In this way, the unimolecular elimination reactions of alkyl halides take place. Again, I must tell you here, as far as the secondary alkyl halides are concerned, they can go through both type of mechanism, E1 as well as E2, depending upon the nature of solvent used. If secondary alkyl halides are reacted in the presence of a non-polar or non-ionizing solvent, they will prefer the E2 mechanism, while the secondary alkyl halides, if reacted in the presence of polar or ionizing solvent, they will prefer E1 mechanism. So secondary alkyl halides can go through both type of mechanisms, E1 as well as E2. Primary alkyl halides can go through the E2 mechanism, while tertiary alkyl halides can go through the E1 mechanism. Now, in E1 reactions, the rate of reaction is directly proportional to the concentration of substrate only, because the attacking nucleophile doesn't appear until unless the breaking of tertiary alkyl halide molecule. So the rate of E1 reactions only depends upon the concentration of substrate, that is the tertiary alkyl halide molecules. This is all about the E1 and E2 reactions of alkyl halides, the elimination reactions of alkyl halides. My dear students, it was also a very important topic from chapter number 8. Now only one topic remains in this chapter, chapter number 8, which is the formation of Grignard as a reagent and their synthetic applications. Inshallah, I will discuss that topic in the upcoming video lecture. So till then, Khuda Hafiz. Assalamu-Alaikum Warahmatullahi Wabarakatuh.